Hey, okay, we're getting near the end. So I thought today in today's lab, we look a little bit at future value and present value because I think it's kind of interesting. It's kind of how like all financial decisions are made. So I think it's kind of useful for you guys to have a look at it. And so here is an example. So when you win the lottery, you see the lottery with the big $1 million jackpots. So quite often you've got two options when you win the lottery. You can have like a payout now of an amount. So this guy won $26 million in the Mass Millions, the Massachusetts State Lottery. And, well, actually, no, they didn't even give the choice in this one. They gave out the $26 million as 20 annual installments of $1,300,000. So your idea is to see why the state lottery did this was right. They actually, because they put money into the future, right? We know that this guy Bruce Hegarty did win $26 million, and he was given $26 million in cash, but the value of that was not $26 million because some of that was put into the future. So if you open up the Excel file, you can see, you can actually go out and you can figure out, based on different interest rates, what actually the present value is. And you see that by doing this, the state actually saves quite a bit of money by doing this. Okay, so it's just an exercise in playing with Excel. So you guys at home, Elijah, Jinru, Matt, and Eric. So yeah, open up that file, Mass Millions, and play with it and answer those questions there. Also, at some point, your team should try to make an appointment with me so that we can discuss the project, which is due in 3 weeks. Usually it needs a little bit of chatting with me just to make sure that you're starting on the right path. Just because quite often you have to do something computational, and we just want to make sure that you just start off right and don't waste a lot of your time. Oh, did I already do that? Actually, I think I might have already. Well, okay, it looks like I've already. I made a mistake and I gave the answer instead of the question. So, so let me talk some more then. So here is the prize. So in this column here, I've done the prize. And here is the number of years that you're going to put the prize over. And so what's that? oh, that's just a percentage, right? So in these columns here, in these 20 rows here, right? So you get your first payment straight away, which means that you get 26 million odd dollars divided by 20, and you multiply it by the negative exponent, but because it's in year 0, A2 is 0, so that means it's e to the 0, so that's 1. So in the first payment, you get the actual full value of your prize, which is this 1,334,000. But you see that as you go along, because it's in the future and we've got a 2% interest rate, that even though it's on face value, it's 1,330,000, its actual present value is actually less. So in fact, in the last payment, the 1,334,000 is actually worth 912,000. And that's because if you take 912,000 now, put it in the bank at 2%, you'll get 1,334,000 at the end of that time. Okay, and so if you just add up all these things here, you get the total present value, which is not 26,680,000, but 22,211,000. And so that's only like 83% of the actual 26 million. So they're saving them 17%. That's if the interest rate is 2%. Okay, so try different interest rates, and you'll see that as the interest rate goes up, what happens when the interest rate goes up? That means money in the future is less valuable, right? Because you need less money now to get that target at a higher interest rate. And so the higher the interest rate, the more they're saving. So go ahead and play with those values then. So your present thing here is you want to fill in this table. You want to find these three values right there. So what was the value when the interest rate is 4%? What percentage of face value do we get? 70%? 70.2%? What about at 6%? 59.9? So now play with the interest rate to try to get to this to be 50. And I'm going to go and try and get a pen while you do guys do that. Did anyone any luck finding this? $8.5. Put in here. 0.085. Yep. Excellent. And so you see how the high interest rates, how easy it is to make up money. Okay, so okay, so that obviously tells us why the lottery commission does not pay the money up front, right? It can make substantial savings by doing it this way. So what we considered, so that answers 1 through 3. So what we considered last Thursday is So that's an example of discrete payments. So what we talked about on Thursday was income streams. And so, of course, money is a discrete thing. So like, people give you payments and that's like a set amount that you get at a set time. But if you're in a business, then quite often you can think of your money as being continuous because, if you have a store here and a store here, the idea is then that that's generating income and you don't think of the discrete transactions, you just think of a flow of money. Okay, and so it's convenient to think of it as just a flow of money because then we can do calculus. We can take derivatives and take any derivatives, etc. It's just like a convenient assumption. So what we discussed on Thursday is that you have an income stream, which we're denoting by S of t, yeah. And that just is a flow of money that comes into the coffers over time. And if we actually want to think, what is that stream worth? Because the income is coming over very many time periods, we've got to bring it back to one time period to be able to compare different income streams. Okay? And so the way that we do that, of course, is by using the interest rate, e to the minus RT. That's the thing that brings money from the future to the present. It brings its value from the future to its present. And so what we do is we can write it as this as a Riemann sum, and we know that that gives us an integral. So if you open up the file stream, oh, here it is. So we've done something where, so now let's say we have some income stream. Someone is giving us $20,000 a year continuously. So let's say we want to know what is that worth over the 2 years. Okay, so what we do, here is our timeline. We're getting money at every instant. And so what we do is we cut it up in a grid of point. And we take the money that we earn within this time period. We take it back to the present using e to the minus RT to get, here is, this has got certain face value. Back here, it's got its present value, and that's what we're going to do. So the way that I've set up this file is I've cut up the 2 years into 20 time intervals. That means each time interval is 1/10 of a year. I've got an interest rate of 6%, and so what is that $20,000 a year worth? Well, if you click on, oops, what have I done? Oh. I click on here, and so I've got I got $1,988, right? So that is my stream, $20,000 a year, $20,000 per year, times my time interval. So that's a tenth of a year. So a tenth of $20,000 is $2,000, right? So this is $2,000 in cash value. But what I've done is I've assumed that I've earned my money. I'm doing a right-hand sum. So I assume that I've earned my money at the end of that tenth of a year. And then I've brought it back a tenth of a year. And so that's what I've done here. E to the minus A2, right? So A2, that's the time period, which is a tenth of a year, times the interest rate. So $2,000 in a tenth of a year time at a 6% interest rate is actually only worth $1,988.04 now. And so what I've done here, so here is my income stream, right? So what I've done here is, well, I then look at the money that I earn in this time period here, and I bring it back 2/10 of a year, and I add it to the present value of that first instant here. So this is giving me the income stream in terms of present value. In terms of face value, right, it would just be 2,000, 2,000, 2,000, 4,000, 6,000, 8,000, 10. We'd just be adding 2,000 each tenth of a year. But we're taking into account what the interest rate is. Okay. And of course, this is just an approximation, because what we're actually doing is we're assuming that we're getting it every tenth of a year, when in fact we're getting it continuously. So what is my point then? Where is the So what I want you to do is, let's see if we can make a better approximation. So let me get, uh-oh. Uh-oh. In trouble. Why is this? It says dry erase. It's not erasing. Crap. Oh crap. Ah, yeah, I'm in trouble. Anyway, okay. So what I'd like you to do is just try a smaller time period. Say try 0.01 and then extend the file and see if you can get a more accurate answer. So somewhere write down this answer, then try a different delta t and see if we're getting convergence. Okay. So how did the present value change if you change the delta t to a smaller delta t? What did you get? Oh, you've got to copy and paste. Remember. So what we should do, say if we want to change it to 0.5, so we want to put n to be, say, 200, then we should go and, oops. Oh. Do that, and then we should do it down like to 200. And so we've got a new value of $37,681. But I don't want to write this up forward, but what we can do is we can do it by an integral, right? Because we see that it's a Riemann sum. So what we should do instead of doing all this, is do this formula that we learned on Thursday. We can take the antiderivative of this, evaluate it between 0 and 2 years, and we can actually find the present value. And then, of course, we can push the present value back 2 years into the future to see how much money we'd actually have. So if we have $20,000 a year, in 2 years, that's $40,000 face value. But that $40,000 is going to be worth less than $40,000 at the beginning, right? Because that's money in the future. And at the end of 2 years, you're going to have more than $40,000 because you're going to have had money beforehand, which you're going to invest it and gotten interest rate from that. So that's the wonder of present value. That's enough for today. I feel like I screwed up with the. I've got to fix that whiteboard and get there. So, have you guys had a chance to have a look at your project yet?
We're going to meet together this week, and then we're going to try to figure out a time to come and talk to you about it.
Okay, that'd be great, because which one are you doing?
We're doing the polynomial.
Right. And so what you want to do is have a look at it, have a little go at it. You know, not try and solve it, but make a start on it so that when you come see me, I can say, yes, you can just do more of that, or no, you're doing it completely wrong. You do whatever. So the main thing is just be efficient in our use of time, right? And also there's lots of questions, you need to break it up. So you go to assign tasks for people. But the thing is, it gets harder as it goes along. That's another thing that you get. So maybe you should do the first part all together and then split up the other bits between. Whatever. Okay. So yeah, I'll look forward to talking to you all. See you, Matt, Elijah, Jinru.